Hi, everybody. This is Joe McIntyre from the Evidence Pilot Course Design team. In this presentation, which is associated with the article on the effects of Sesame Street, we're going to be talking about some of the key ideas in assessing the quality of quasi-experimental evidence. And as before, we should start by asking, what is quasi-experimental evidence? We are talking about quasi-experimental evidence as evidence of a causal effect, but that does not come from an experiment. If it came from an experiment, we'd call it experimental evidence. So to make this clear, I want you to imagine once again that we have some assembly of people who are either going to be in a treatment condition or in a control condition. In this case, the treatment condition is watching Sesame Street, and the control condition is not watching Sesame Street. And unlike in an experiment, we've got children who have self-selected or have been selected by their parents to either view Sesame Street or not view Sesame Street. So it would seem like a straightforward way to figure out the effect of Sesame Street might be just to compare outcomes between these two groups. And unfortunately, that would be a terrible mistake on our part. The reason for this being that the fact that people have self-selected into the two conditions means that they could be different in systematic ways that have nothing to do with Sesame Street itself. So it's possible, for example, that children of high income parents or highly educated parents are more likely to choose to view Sesame Street than those that don't. And any differences that we see between the two groups may be due to those differences and have nothing to do with actually watching Sesame Street itself. So that would be a mistake. So let's think about this a little bit differently. So now, and this is again from the paper that you read, instead of thinking of the two conditions as either watching Sesame Street or not watching Sesame Street, let's think of them as living in an area where there's good coverage of Sesame Street, where people have access to Sesame Street, and living in an area where people can't watch Sesame Street. It seems a lot more plausible that these folks have been randomized into these two conditions, because it seems really unlikely to us that people moved to areas just so that they would be able to watch Sesame Street when it became available in 1969. So we've got something that looks a little bit more like random assignment. And essentially what we're going to do, and what the authors did in the paper, is look for differences between people who lived in areas where most people could watch Sesame Street and people who lived in areas where most people could not watch Sesame Street, and use that as an estimate of the causal effect. And as we'll see a little bit later, their approach is actually a little bit more complex and robust, but that's the basic insight that they're using. They're trying to find a causal effect due to some natural randomization, because they are not able to actually randomly assign people. So what this is referred to as is the identification strategy that they're using. So an identification strategy is the way that the research separates causal effects from other reasons for differences. Essentially, an identification strategy takes advantages of certain features of the data. Here it's going to be geographic variability in access to Sesame Street. And it uses these to produce estimates of causal effects. Now, there are lots of different identification strategies, and which one you select is going to depend on what features are present in the data. However, there are some common ones that get used a lot, and we're going to cover two of them just to give you a taste for some of the things that people do. The first one, which is not used in the paper that we discussed, is something called regression discontinuity. What this comes down to is when we have a variable that is used to assign treatment, say test scores are used to determine who gets accepted into college, we can estimate a causal effect of the treatment, here being enrolled in college, by looking at differences between people who just barely managed to get into college and people who just barely did not manage to get into college. So that's what this plot is trying to show. On the x-axis, we're imagining we have test scores on some sort of a scale. On the y-axis, we have some outcome of interest. Maybe it's income 10 years after, or income at age 25. And we're going to assume that people are able to be accepted into college if their test score is 0 or higher, and they're not if their test score is below 0. We could estimate a causal effect of college by essentially comparing people who had test scores that were just barely high enough to be accepted to people who had test scores that were just barely low enough not to be accepted. because we might think that people who could almost have been accepted to college but weren't quite able to should serve as a good counterfactual for what would have happened to people who just barely got into college had they not gotten into college. And in this case, we're going to call the treatment effect that gap there, the gap in the average scores for people who just barely managed to get into college and people who just barely did not manage to. Well, that's a regression discontinuity. It's a commonly used quasi-experimental technique. A little bit closer to what's actually used in the paper that you read, something called differences in differences. Essentially what you're doing here is you're looking at changes in the treated units over time compared to changes in the control units over time. So again, I want you to consider the following plot. On the left-hand side, the dots are showing observed scores for treated units and untreated units. Let's say average observed scores for treated and untreated units. On the right-hand side, the red dot is indicating the observed score for the non-treated units, the control units. The top blue dot is showing the observed score for the treated units, and that sort of middle blue dot is showing the hypothetical score or the counterfactual score for treated units. And the basic idea behind this is we're not going to assume that the treated and untreated units are the same. We can see that even prior to the intervention, treated units have a higher score than control units. But what we are going to assume is that had the treated units not been treated, the trend from the control units is probably what would have happened to them. And so if we want to see where the treated units would have ended up absent the intervention, we can start where we observed the treated units, and we can follow the control unit trend, which gives us this point. Essentially what we're saying is that if they had not been treated, the treated units would have behaved over time just like the control units. And as you can probably imagine, in this case, we could estimate the treatment effect by taking the difference between what we actually observed for the treated units and what we expected they would have had based on the control unit trend. It's called the differences in differences approach. That's another identification strategy which is used sometimes to produce causal effect estimates from data without randomization. Now let's talk about how the paper actually obtains its causal effect estimates. So the first thing that the researchers did was they observed that in 1969 there was different counties in the United States had different coverage by stations broadcasting Sesame Streets. There were some counties where almost nobody could view this because they didn't have the right kind of TVs or because of how it was being broadcast, or there wasn't a local PBS station. And there were other counties that had much higher coverage. And so the basic idea of this research is to just compare long-term outcomes of people who were young in 1969 who lived in high coverage counties and those who lived in low coverage counties, and differences between their long-term outcomes might be taken as evidence of a treatment effect. Although if you're familiar with American geography, you may notice that the areas that had high coverage are quite unlike the areas that had low coverage. So most of the eastern seaboard, most major metropolitan areas have high coverage, whereas there are huge parts of the American South, of the American West, of some of the Appalachian areas that have almost no coverage whatsoever. And so making comparisons between these two groups directly may have led to a confounding of treatment effect with regional differences. And so the researchers added another element to their identification strategy. So what they did was they looked at people in these various counties who were young enough in 1969 that they probably would have watched Sesame Street, and those who were old enough that they probably hadn't. And so essentially what they did is they identified high exposure counties, and they looked at the gap in outcomes between people who were younger and people who were older. So that's the gap in high exposure counties. And then they found the same gap in low exposure counties. And this is where this starts to feel like a differences in differences, because essentially what they did then is they said, well, if we take the gap between younger and older people in terms of long-term outcomes from the high exposure counties, and we subtract the gap from the low exposure counties, then the remaining difference is the treatment effect. And that's their basic argument. And they use that to produce this plot here. and this is specifically for students being at grade level in 1980. And what they did to sort of convince us that this strategy makes sense is that they use the same method to estimate the quote-unquote treatment effect of Sesame Street before Sesame Street was actually released in these areas. And what we should hope is that when we're looking at people who are too young, when we're looking at children who prior to Sesame Street actually being released in these areas, we should not find a treatment effect using this method because, of course, these people weren't exposed to Sesame Street at all. They didn't live in an area or in a time when Sesame Street was available. And that's exactly what we see in the 3 years prior to Sesame Street. We fail to see any evidence of a difference in these different counties. And in contrast, after Sesame Street was released, that's when we start seeing differences based on student age and being in a high exposure versus a low exposure county. And so this provides additional evidence for us that this approach to identifying the causal effect was effective. So in assessing the quality of this evidence, in addition to all the other things we've talked about in terms of experimental evidence, we should be asking ourselves, how convincing are these data that the effect that we're seeing, the difference that we're seeing, is actually a causal effect and not just a difference between different sorts of children?